This is my 24-volt battery made out of 6 Nissan Leaf modules. Brand new, these guys had about 3 kilowatts of capacity. Now they're probably storing about 2 kilowatt hours of power. I have it set up with a 200 amp breaker and 175 amp Anderson connector that goes directly to the inverter, which runs my well pump. And I also have a secondary discharging circuit over here that's on a 40 amp breaker, has an XT60 connector on it. When I'm using this on my well pump, I basically have no BMS in the loop, so it's up to me to make sure none of these cells get discharged too far. When I'm charging it, I have a bulk charger that can charge it quickly if I need to in a power outage, and then I have this little RC aircraft charger, and I have leads off of each cell that plug into this guy, so this is a smart balancing charger, and that's how I make sure that the cells stay balanced when I'm charging or using it. Now, I'm planning on using this guy to power my boat, and I'm also eventually planning on putting a solar panel on the boat to keep it charged up and topped off. And for unattended charging like that, I need to have a permanently attached BMS. So I went out and bought this BMS here, and essentially how it connects up is we're going to take the negative from the battery into here, and then the negative from the power going to where this guy would be. So it sits in line with the negative side, and it has the power to cut that off if it gets charged too high or if a cell goes too low. I also have to connect up all these little sense leads here to the appropriate places there. It has a Bluetooth app that'll control the whole thing. I have purchased the optional LCD control panel, touchscreen control panel. I may or may not end up using that, but I decided to buy it all at the same time just in case I want a little bit of control on the boat without having to get a phone out. It also comes with a couple of temperature leads that I can snake in between the cells, and it'll make sure the cells don't get too hot or too cold. But realistically, I'm not going to be charging or drawing too much out of this guy, so I'm not worried about heat so much as I just want to make sure when I have this thing with the solar charger on it, this guy will keep the cells in balance and cut off that charging if it's getting too high of a voltage. And of course, if somebody's using the boat for too long, I want to make sure it'll cut that off to protect the battery too. The BMS came with its own set of sense wires. This side plugs into the BMS and these side are just bare wires. Instead of wiring these in directly, I'm going to make an adapter that hooks into this little type of cable. This is an RC aircraft cable, and these guys just unplug. I put a couple of extensions together so I can get it low enough, and that way I can unplug the BMS and plug this guy in if I want to charge it with this guy and do balance charging with this. Technically, I don't really need to do that. I could just plug just this thing in and charge it and let the BMS balance it, but I figure I might as well keep a connector there that I can unplug just for flexibility in the future. If you want to learn more about this battery, how I put it together, what all the meters and pre-charge resistor things do, I have 2 videos where I constructed this battery, so you can go and look at those. So I'm going to be working around some, it's low voltage, it's only 24 volts, but a whole bunch of amps are in there. So I'm taking off anything metal I have, like rings and watch bands, just because if I were to bridge something, I don't want it sparking and welding itself and heating up really fast. Also, you don't want to drop screws down in your battery. The positive side of this lead already goes through a circuit breaker. The negative side is going directly to the battery. That's what this is going to interrupt. I'm going to take the negative battery to B-, and then the negative from the power input or output will go to this P- right here. They have mounting holes, but space is a little tight, so I'm probably going to be using double-sided sticky tape just to stick this thing right there. I want it within the rails of this plywood here so that something won't hit it if I lay this battery on its side. Now I'm hoping to reuse this black cable just as it is and just create one new cable to go from there to the BMS. But first I'm going to take this thing so it's not connected to the battery. The other side, I have the circuit breakers disconnecting the other side from the battery. So I have to take that off. I have my wrench wrapped in electrical tape so that if it falls it's less likely to bridge 2 of these copper bus bars, because that would be a lot of amps going through there. And you also don't want to be dropping nuts and washers inside the battery with all these bus bars here. So I'm being careful to remove those carefully. And of course you wouldn't want to bridge something with something like that either, so you want to make sure that's not going to be bouncing around as you move things around. I found this really flexible welding cable that already has the right size lug and the right size wire. It's just super long. I need to cut it off and put another lug on the other end so I can use that to hook the battery to this guy. So if you can, I recommend welding cable for these types of jobs. I make a lot of high voltage, high current cables, so I have lots of selections of lugs and cable terminators and so forth. Alright, I stripped the wire here so it's appropriate for that lug. This is dual wall adhesive shrink tubing, so it kind of has hot glue built into it, and so when you hit it with a heat gun, it not only shrinks, the glue also sticks it to everything. So you want to put that on before you crimp your lug so you can put this back out and then shrink it on top of that thing. So this is 8mm squared or 8 gauge wire, and that's right at the edge of do you need a hydraulic crimper or not, but since I have a hydraulic crimper I'm definitely going to use it. So I clamp the lug down until it holds itself in there, then I push and hold the wire in, and then we apply hydraulic pressure. And there she is. If you heated that guy up enough, you will see a little bit of a clear residue that's basically hot glue that escapes all the way around. And you know, if that goes all the way around, it's sealing this thing to that thing to prevent water getting in there. Nothing in the documentation, and I say documentation with air quotes here, that I received with this thing, a couple of pictures on the website, say what threading these guys are, but they're basically metal plates that have been soldered in here, and they have they take threads for M6 screws. Now my screws here, the M6 screws I happen to have, would stick out the back far enough to touch things behind it, and I definitely don't want that. Even though it's battery negative, I don't particularly want to connect this case to battery negative. So I'm probably going to have to order short screws or cut these guys off and then follow them out with an M6 die, which I do have an M6 die. I could also screw them in from the back and then use an M6 nut to hold things down onto them, but I don't have any M6 nuts, so that's how much too far my existing screws stick out the bottom. So I can cut these screws off, and if I don't mess up the threads too badly, I can use them. Otherwise, I can measure that and figure out what I need to order. I should point out, I do have a lathe. I just can't be bothered to get it out and set it up. So before I cut that screw off, I was sure to verify that an M6x1 die screws on there pretty nicely, so I am very confident that's an M6x1 screw threading. And I just use a screwdriver to screw that thing into the die and then back out again to kind of chase those threads out and hopefully make it so it's going to work well into the BMS threads. Alright, we have success there, and you can see that guy doesn't stick out any farther than the solder joints on the bottom, so I'm not risking, pushing that negative battery terminal into anything. I don't think you'll be able to see this, but a 1/4 inch lock washer will fit on an M6 metric shaft, and so I do have a little 1/4 inch lock washer in there between the screw and the lug, and then the lug connects directly to the power terminal. Okay, you can see that I just barely have enough clearance for those power wires. I verified everything's going to fit where it needs to be. I have these BMS wires here coming out, and they need to go up and plug into that thing. So that's about as much length as I need for these guys, and I'm going to have to attach them to the appropriate places at the end of this guy so they can plug in up there. So this BMS supports batteries between 4 cells and 8 cells. So I have a 6-cell battery, so 2 of these wires are going to be unused. So what we have is the most negative here is battery minus. That's to the negative side of your first cell. And then you have battery 1, which will go to the positive side of your first cell. And then you have battery 2, which is positive side of your second cell, positive side of your third cell, positive side of your fourth cell, positive side of your fifth cell, and positive side of your sixth cell. We have 2 unused wires because I don't have a 7th or 8th cell, and then we have B+, which is the positive of your total battery. Now the positive of my total battery is the same as the positive of my 6th cell, so these 2 are going to be tied together and attached to my most positive side of the battery. Of course, the coloring scheme of these guys is exactly opposite. This guy marks the most negative side on the right, and this guy marks the most positive side on the left, but I can figure that out. Alright, after an annoyingly long time soldering, I have each of the wires from this connector connected to each of the wires from that connector, minus these 2, which are unconnected because I only have a 6-cell battery. I have, you can see the 2 here, the battery plus and the top of the 6th cell are both going to my top of my 6th cell. The only advice I have for you here is make sure you put the heat shrink tubing on before you solder these up, so you can put the heat shrink tubing over these when you're done. And also double check all your connections, because I messed one up, and if I hadn't double checked I wouldn't have caught it. I would have had a reversed battery 5 and 6 top. I'm not sure if that would have blown anything up, but it definitely wouldn't have reported correctly. Alright, I just taped those together a little bit to keep them from jumping around on me. Alright, I plugged in the sense wires and nothing blew up. That's good. I don't have any fuses on these, but they're 22 gauge, so they act as their own fuse if something horribly wrong happens. I'm going to hook up the negative lead here. Okay, everything's hooked up. Now, it hasn't made any noise or beeped or turned on or anything. There is a procedure to activate the BMS. And what they say to do is to hook up a charger that's at least 4 volts more than the batteries to this guy, and that'll just turn on the BMS. So I'm going to work on physical hardware mounting here first, and then I'll worry about activating it by hooking up a charger, a non-smart charger that can put a little voltage in and turn things on. So I'm just going to be using this maximum strength multi-service Scotch mount double-sided tape. Alright, it's not perfectly level, but after I clamp that in place for 20 or 30 minutes, I don't think that Scotch Extreme tape is going to be coming off. So I paid extra to get the touchscreen LCD controller, and it came with a button which plugs into this bit of wire, and it came with a cable which also has a fancy through bulkhead type connector, which I've hooked up, another connector, and then this thing here that'll actually plug into the bottom of the BMS. So I'm going to plug that into the BMS and push this button and see if that activates things without having to hook a charger up to it. And if that doesn't work, then I'll get my power supply out and set the voltage to 28 volts or so and plug it in and see if I can get this thing to activate. So the temperature sensors came plugged into this guy, labeled in Chinese. We have RS-485 connection here, a GPS connection there, and then 2 other Chinese labels. My reading of the manual indicates that this guy is the LCD and that's the heater. And they say something about the heater requiring extra configuration, so I suspect that's something where you can control a battery heater if you wanted it. Luckily they're different sizes, and this one only fits in that guy there, so I feel pretty comfortable plugging this guy in because it fits that guy and it doesn't fit this guy. So we're going to plug this LCD connector in and see if it does anything before I apply power on the charging side of stuff. Alright, I'm hoping this cable and button has some type of interrupt where I just push it and things activate. Oh, it beeped. A light came on. 3 beeps. We got a light flashing in here that was red flashing light. Somewhat turned on. Now this guy has not been active yet. So scanning the QR code on the device led me to a website with links both to the direct downloads of the APKs, but also to a Google Web Store, or the Google App Store official install. So I've installed this thing from the Google App Store, which is about as safe as you can get. We're going to see if I can find it. So yes, we have to allow location access to use the Bluetooth. The application encountered fatal error and cannot continue. Well, that doesn't sound good. Let's try this again. Fatal error, cannot continue. I've installed it on a more modern phone, and it is scanning. It found a device, so I'm clicking on the device. It's going to ask for a password. The default pairing is 1, 2, 3, 4 according to the manual. It's pairing. Okay, and we are connected, and it has some data. Cell count is not equal to settings. That's not surprising. So I am going to go in here, and my cell count defaults to 8 because it's an 8-cell BMS. I need to verify the password to be able to change these things. So the password is 1, 2, 3, 4, 5. I think it has a 6 at the end. Yes, it looks like I have it there. Alright, so that's the default. We're changing this to 6 cells and hit OK. Okay, I believe I've found settings that work for my battery. I'm using their lithium-ion default settings. You need to change this to 6 cells and push that OK button to save that. And at that point, it doesn't give you any more alarms. You can see your voltage and stuff. There's a lot of other settings in there. Right now, under the advanced settings, it has the over voltage protection at 4.2 volts. There's under voltage protection, which is 2.8. Okay, so right now I'm not getting any real voltage coming through this. It's like 0.7 volts, but I'm sure the amperage is super low and it's going down. So there is a control section of this app, and balance is turned on, but the charge and discharge are turned off, and emergency is turned off. I don't think I want emergency on, but discharge might be useful. So I'm going to flip discharge to on, and now this goes up to 24.2 volts. So when I turn discharge off, this thing goes down. So that apparently is what turns on and off the basically the big MOSFETs that connect the power out to the battery. Okay, a setting I want to change is the battery capacity in amp hours. This should be 120 amp hours when these cells were brand new, but they're not, so I'm going to set it to 100 amp hours. I think that's a pretty reasonable estimate of what the capacity is right now. Alright, using my multimeter, which I trust a little bit more than the Chinese-made BMS, I've gotten 24.27 both on the output and just the raw cells is 24.27. So there's a thing here that's calibrating voltage is 24.7. I'm going to change that to 24.27, hit OK. And so I'm hopeful that now my battery voltage here says 24.27. So hopefully that's calibrated it a little bit. There's also a current calibration, but because I don't have any current draw going on right now, and I don't have a current meter hooked up to the little plug, the current meter's on the big plug, I'm not going to bother doing the current calibration right now. Alright, I verified that the temperature sensor 1 here goes up to 34 centigrade when I'm holding it in my hand versus 25 for ambient. And then the temperature sensor 2 here is the one on the right hand side as you're looking at the bottom of the BMS, and I'm verifying that it does also detect temperature. So I am just going to run these guys up a couple of slots in here, so they will be kind of next to the battery case, and get those wires out of the way. They're not really embedded inside the batteries because these modules are pretty kind of solid. I'm not going to be able to get into them easily, but I'm just going to get those wires out of the way and get the temperature sensors kind of near the batteries. Now this meter here hasn't done anything, and there's 2 wires attached to it that aren't hooked to anything, and there's only 3 wires coming from the battery, and they're pretty thin. So my suspicion here is that I need to power this meter separately, and it's not taking power from the BMS and the battery, so these are probably just data communication type wires. So I'm going to go see if I can look at the Chinese manual, and hopefully it'll have a voltage reading in English characters that I can read and try to figure out an idea of what type of voltage might go in here. You assume that red would be positive and I guess yellow would be negative. There's some markings on the circuit board, but I don't see anything that says like 12 volts or 5 volts. So I'm going to go see if I can read a manual, see what I can do about getting this meter working. Right, over here I have my battery charger, which is just basically a constant voltage power supply with current limit and so forth. I am going to plug this in because I want to see how well the BMS deals with that. So first, just if it detects charging and so forth. So I'm going to turn this thing on, and the voltage did go up. So it did detect the voltage going up. I have a thing that's battery power, 307 watts, so I believe it's detecting that the power is going in. The balance current has just turned on, so I have a negative 2 amps on the balance current. So apparently it is balancing one of these. So one of my cells is flashing. It is a blue cell. So the blue one's the highest one, 4.06. So it does look like it is actively balancing the cells as if this guy is charging. 10.9 amps, so that's correct. So it's basically getting 10.9 amps in. Okay, I went into the settings and I modified the overprotection cell voltage to 4.075, which was just above what my highest cell was. Then I plugged it in the charger and started charging, and almost immediately it says, hey, protection, cell over voltage, and it turned off the charging, and so there's 0 amps coming in even though the charger's still turned on. This thing here is lit up, but essentially it turned off the charging. So that's good, because I want this thing to be able to disconnect from a solar charger automatically if one of these cells goes over voltage. Alright, I couldn't find any English documentation for this guy, and nobody's responded to my questions about how much voltage it takes. So it says on the circuit board, it says VN and ground. So the red is VN and yellow is attached to ground. I'm just going to hook it up to my bench power supply. It's 5 volts and see if it turns on at 5 volts. If that doesn't work, I'll try 12 volts. Alright, at 5 volts, this draw is drawing a tiny little amount of current, and there's nothing on the screen. It might need to be plugged into the BMS for something to happen, but it also might need more than 5 volts. So I'm going to pop this guy up to 12 and see what happens. Okay, I popped it up to 12 volts. It's drawing 120 milliamps here. And we had a boot screen and the displays popping up, and this guy here is obviously not connected to the BMS, so nothing's happening, but it appears to be working correctly. So it looks like 12 volts is good. I don't know about 24 volts. I'm afraid to go higher than 12 volts. I probably am not going to end up using this touchscreen just because I've found that the phone app works pretty well. Alright, I have the JK touchscreen LCD attached to the battery BMS system with an external 12 volt supply here. So there's a little boot up screen, and off we go. So no need for a password. It has no need for pairing since it's a physical wire. It has in your status your battery's capacity there, no current in and out, the voltage. We have the temperatures 23 centigrade. I don't know which of the temperature probes that is, or if that's an average from everything. From the 2 temperature probes, the MOS 24C is from the MOSFETs. No alarm. Delta voltage is very low. Your average voltage, your balances aren't, your charges aren't, your discharges aren't. So you hit cell voltage, it'll show you the individual cell voltage. No fancy reflow of the UI based on the number of cells you have. It basically just says, hey, I can do up to 24 cells, but your battery only has 6, so here's your 6 cells. No bar graphs or anything like that. And it has an alarm screen, and there's no alarms. So it does not appear to have a way to change these items. It is a touch screen, at least the bottom 3 areas are touchable. But I have not found anything that would be adjusting anything. So it looks like you're going to have to use the phone app for any adjustments. And this is merely a display to show you information. If this was powered by the BMS, That would be kind of nice, so that this cable that, you run this cable out to the BMS would provide power as well. But it's not. You need an external power. I don't know the minimum and maximum voltage. I know it doesn't work on 5 volts, and 12 volts it seems to work just fine. I'm kind of afraid to try to go to 24 volts, so I don't know if I want to run this off my 24 volt battery system. And I'm not going to make a step-down converter just to run this display, so I'm probably just going to omit using the display. I got it because I wanted to have all the options, and it was kind of useful to have this cable, because the cable comes with this button, which is kind of the reset the BMS button, and that's very useful. When you first plug this in, I just pushed that button and it started working. It turned on and started working. Otherwise, you have to put a charger on that's like 4 volts higher than the battery, and put extra voltage in, and that's a trigger to the BMS that, hey, I need to turn on and start working. So it was kind of nice to have that button just to activate the BMS when I got started. I wanted to have this on hand just in case I want to use it in the future or decide to use it now. I don't think I'm going to be using it for this particular project. From a mounting hardware standpoint, they came with 2 of these little brackets and screws, and it's a pretty typical panel mount where you have, you cut a square hole in your panel and there's this lip around the edge. I'm not quite certain how you're supposed to use these guys. They obviously fit into these 2 little slots. There's some on the top and bottom. So if you put them in and push them forward, they will kind of catch in there. So I'm not sure if you're supposed to reverse these screws, put these in this way, and then push the screw against the back of the panel from the inside, or if you're supposed to have a hole drilled from the outside that pulls these guys in here against the panel, or I'm not sure exactly how that's supposed to work. The hole is very close to the top edge of that panel there. So yeah, I'm not quite sure how those brackets are supposed to be used, but I'm assuming that there is some design for how those brackets actually work. So the LCD screen comes with all the cables you need to attach it to the JK BMS. This little thing here actually plugs into the BMS. It's a pigtail that goes to this adapter here, which adapts to this black cable, and they have kind of a bulkhead connector here with a cover over it, so you could mount this on the battery box and then have the meter separate that plugs into that separately. Then there's a pretty long cable, 6-7 feet here, back up to just kind of bare ends, and they have a connector here that hooks into a push button that's the reset the BMS button, and then this guy here plugs into the back of the meter, and then these red and yellow wires are where you provide external power to the meter. I know 12 volts positive there, negative here works for this meter. I don't know the exact upper limit of the voltage range there.